Welcome! In this video, I'll show you how to configure limited access to an AWS account using the AWS Identity and Access Management, or IAM, service. This diagram shows what I will accomplish in this demonstration. A few cafe employees need access to one of the cafe's AWS accounts to perform their roles. One of those users is Nikhil. He needs access to the account to perform the role of an application developer. Meanwhile, Sophia, the account administrator, wants to follow the security best practice of granting least privilege to users. That is, she wants to grant Nikhil only the permissions he needs to perform his tasks. In this demonstration, I'll play the role of Sophia and act as the account administrator. I'll first create an IAM group. Then I'll attach the needed IAM policies to the group. And third, I'll create an IAM user for Nikhil and make him a member of the group. Finally, I'll test logging in as the Nikhil user to verify the account access is what I intended. Okay, let's get started. I'm logged into the AWS Management Console as voclabs/user. You can see this in the menu bar in the upper right corner of the console. For this demonstration, I'll pretend that this voclabs user is Sophia from the cafe. She has full administrative access in the account, so she can create and configure IAM resources. So first I'll navigate to the IAM console. Next, I'll create an IAM group. Other cafe employees or consultants might need access to the cafe's AWS account in the future. By defining a group for this purpose, it will be easier to manage the access granted to these users. It promotes more consistent permissions granting across multiple users as well. I'll name the group App Developers. Next, in the Permissions Policies section, I can search for and attach existing IAM policies to the group. Nikhil and other developers need to be able to see the EC2 instances in the account and do actions like find out the public IP address of an instance so that they can connect to it. However, I don't want to allow them to create new EC2 instances. Given this criteria, I'll grant read-only access to Amazon EC2. And I'll go ahead and create this group. There we go. As you can see, the group currently has 0 users in it. Now I'll go to the IAM users area and add a user. The username is Nikhil. For access type, I'll select both programmatic access and AWS Management Console access. Programmatic access means that he can use the access key and secret key to configure his laptop to use the AWS command line interface, known as the AWS CLI, to perform actions for this account. He can also run code that uses the AWS SDKs to interact with this account. Console access means that he can log into the AWS Management Console, like I'm doing now. For console access, I'll create a custom password that I can remember easily. I'll uncheck Require Password Reset, and for the next few screens, I'll accept the default settings. Finally, I'll create the user. Notice this warning that the user has no permissions. That's okay, because in a moment I'll add the user to an IAM group to grant permissions. Normally I would download the access key pair right now by choosing download.csv. In fact, this is the only time that I could do that. However, I will not use the programmatic access in this demonstration, so I'll just skip this download. Great. So I've created the group and I've created the user. Now I need to make Nikhil a member of the App Developers group. I'll choose User Groups, choose the name of the group, and choose Add User and add him to this group. That's done. However, let's see what level of access Nikhil will have from being in this group. Let's look at the Amazon EC2 read-only access policy details. Here you can see that the policy allows EC2 to describe actions and also allows some read-only actions for Amazon CloudWatch. Why is this? Well, CloudWatch is a monitoring service, and some of the charts and other information in the Amazon EC2 console about the status of EC2 instances are from data that CloudWatch collects. Without these permissions, those areas of the Amazon EC2 console would not display data to users. Okay, so I'm logged into the AWS account as the Voclabs user, who I'm pretending is Sophia. Now I'm going to open a new browser window to log in to the account as Nikhil. I'm going to use an incognito or private browser session. This is convenient for testing purposes because I can stay logged into the console as the Voclabs user in a regular non-incognito browser session, and at the same time I can use an incognito session to log in to the same account as another user such as Nikhil. I can switch back and forth between the two user access levels without logging out or logging in repeatedly. The authenticated session information from the incognito browser session remains isolated from the other regular browser session. First, I need to find the URL that Nikhil should use to log in. In the window where I'm logged in as the Voclabs user, Sophia, I go to the Users section and choose Nikhil. On the Security Credentials tab, I find the console sign-in link. I'll copy the URL now, and I'll load that page into the incognito window. Notice that this login page looks different than the root account login page. The page already displays the account ID. For username, I'll enter Nikhil, and I'll type in the password I created. Finally, I'll sign in. Great. Nikhil has now authenticated to the account. You can see that I'm logged in as Nikhil because his name displays in the upper right corner of the console. Next, let's test Nikhil's level of access. Recall that he should have read-only access to Amazon EC2. I'll go ahead and open the Amazon EC2 console. Notice that the region I'm currently in displays in the upper right corner of the screen. I'm currently in the US East 1 region, Northern Virginia. If I was in a different region, I would change to US East 1 because that is where the cafe has some running instances. In the console, Nikhil can see how many instances are running. I'll choose Security Groups in the navigation pane, and you can see that a few exist. Now, I'll try to create a security group. I shouldn't be able to because Nikhil has read-only access in Amazon EC2. Look at that, an error message says that Nikhil is not authorized to perform this operation, just like I expected. Nikhil was granted read-only access to the Amazon EC2 service. He does not have permissions to create Amazon EC2 resources, including security groups. Let's try accessing the Amazon Simple Storage Service, or Amazon S3 console, as Nikhil. I can go to the console, but I can't see anything. That's because Nikhil doesn't have permissions to access Amazon S3 at all, not even read-only access. He can't even list buckets. Nikhil is authenticated to the account, but he is not authorized to interact with the Amazon S3 service. I'll try one more test. I'll go back to the browser window where I'm logged in as Sophia with the Voclabs user. I'll go to the Amazon EC2 console and try to create a new security group called Test. And look at that. As this user, I am authorized to create a security group. In summary, you've seen how to use the console to create an IAM user and grant limited permissions for the AWS account to that user. I could have attached the IAM policies directly to the Nikhil user instead of creating an IAM group, but I did this because attaching policies to a group and then adding users to the group is more scalable. In the future, if another developer needs the same permissions as Nikhil, I can quickly create a new IAM user and add that user to the IAM group. That concludes this demonstration. Thanks for watching.